In this video, I introduce the observer design pattern, just the idea and the structure. In a follow-up video, I show how to apply it to the problem from the previous video, that one about the temperature measurements. That problem was about a sensor measuring temperatures, and for every measurement, multiple classes wanted to react. A monitor should show the latest measurement, a log file should be updated for historic reasons, and there was an alert shown if the temperature got too low. So, in short, the problem was that many classes were interested in the change of one other class, the source. This source directly called each of the interested classes in my poor solution, and each time an interested class needed to be added or removed from the system, the source class, that was the temperature sensor, had to be updated. This was simply inflexible. Every new change required existing code to be modified. So the observer pattern comes to the rescue. But first, I want to get some terminology in place. In the original pattern, we had something called an observable. That would be our source, or temperature sensor. And we had observers, which are the classes interested in the changes. I want to rename these. I tend to fumble over observer and observable too often. And in newer terms, you will more often see listener being used. So I will rename the original terms. Observable becomes subject, and observer becomes listener. Okay, let's see the pattern now. I will show the original version, but it has a few things I don't like, so I will quickly modify it a bit. First, I have the subject, which was the sensor. In the diagram here, I will call it concrete subject. It might have some data of whatever type, and there might be a method which updates the data. Then we had one or more listeners. I will just add a concrete listener class here. This one represents, for example, the UI class or the sensor log. It had some method used to react to the change it is interested in. And what I did with the poor solution was just create an association from concrete subject to concrete listener, so the react method could be called directly. But that was a poor idea, as I have explained, so let's undo this. Instead, the observer pattern specifies two new components. First, the listener interface, originally called observer. It defines a method, update, which takes a subject as parameter. If a class wanted to become a listener so that it can react to changes, it will implement this interface. The concrete listener would have to override the update method, which could then call the react method. And what is this subject? It is an abstract class which provides some helper functionality. It will contain a list of listeners. There are methods to add or remove listeners. And then the last method, notify. This one is protected, so only subclasses can call it. The purpose of the notify method is to iterate over the list of listeners, and for each listener call the update method with the concrete subject instance itself. Any class who wants to become a subject, so they can notify listeners about updates, can now extend this abstract superclass, the subject, and thereby inherit the subject functionality. The idea is then listeners can be added to the subject. The subject only knows about the listener interface, not any concrete implementations like the UI class or sensor log, just the interface. That creates flexibility because all listeners are treated the same way, and adding or removing listeners does not affect the concrete subject at all. We are missing one last thing though. Whenever the concrete listener is updated, it receives an object of type subject, but it's really the concrete subject. The concrete listener will then cast the subject argument to its actual type, the concrete subject, and on this object call some get method to retrieve the latest data. So we need a get method on the concrete subject, which the concrete listener can call. We have now achieved more decoupling. The concrete subject does not know about any concrete listeners, and that creates flexibility. I do have a slight issue though. We still have a dependency from concrete listener to concrete subject. I'm not a fan of that, and I want to remove it. To do that, instead of the listener interface's update method accepting a subject argument, I want it to be an object. That object is now the actual data which changed instead of an instance of the concrete subject. Now the concrete listener no longer needs to call on the concrete subject, and we can remove that dependency. And we don't need the getData method anymore either. Now, there may be situations where it's still a good idea to send the subject along, maybe if many different things can change and each listener wants different things. But there are other ways to solve that, as we will see in later videos. So, just one last time to explain the flow of things, I will use my temperature example here to make it concrete. First, I have the sensor class. Its method is called, so it updates its data. That method call came from a thread. It will do that update. Then it will call the notify method from the subject superclass with the new data. The subject will loop over all attached listeners and call their update method. Now, that update method is, of course, actually in the concrete listener. Here, that's the UI class. I just include the listener interface in the diagram for completeness. The UI class will update its label, and then it's done. After the subject has notified all listeners, that is done too. And the sensors method is done as well. Then, after a second, it all starts over. Okay, that's the idea. Because of the subject superclass, we have reusability. All future classes who wishes to notify about changes just extends this class. We have flexibility because there is just the one listener interface, and all classes interested in the changes from the source can just implement the interface and be added as a listener. The concrete subject remains unmodified, at least after it has extended the subject abstract superclass. In the next video, I will apply this to the code example. For now, thank you for watching.